Hello all, so welcome to our 5th free response review video, and today we're going to be focusing on questions that involve tabular data. So there is a lot of different concepts that keep being repeated through these questions, and this is a really huge topic. Every single exam from 2014 back to 2006 has one of these tabular data questions on them. We've already done a few during review classes, but I really want to focus in on them now. A lot of the concepts that you're going to be seeing again and again are average rate of change, or AROC. Compare that with average value of a function. We're going to be doing a lot of Riemann sums as we move through these problems. And then the concept of IVT, which is the intermediate value theorem, will come up, as well as the mean value theorem, NVT. So let's go ahead and get started. We're going to take a look at two different AP questions tonight, one from 2013 and one from 2012. So here we go. Okay, so let's get started with 2013 number 3, and this is a question that is to be done without our calculator. So you can see here we're given a table of values, and we're told that hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t, 0 to 6, is given by a differentiable function c, where t is measured in minutes. Selected values of c of t, measured in ounces, are given in the table above. Okay, so our first question here asks us to use the data in the table to approximate c prime of 35. In other words, the slope of c at 3.5 or the derivative of c at 3.5. Show the computations that lead to your answer and indicate units of measure. Okay, now obviously because we are not given a function, this question comes up very frequently. We are not given an actual function, we're just given a table of values. So we are asked to we can only approximate the value of the derivative at 3.5. And the way that we have to do that is by going back in our brain, what is derivative synonymous with? And hopefully you're telling me slope. And so what we can do is choose 2 points that are equally away from 3.5 on our table. So here these points would be 3, 11.2, and 4, 12.8. And so I'm ready now to go ahead and calculate the approximate derivative of c at 3.5. Okay, so if I were to write out kind of a formula here, I would say that if I was calculating the slope, it would be the change in y for these values. So that's c of 4 minus c of 3 over the change in x's, which is, of course, 4 minus 3. And so c of 4, of course, is 12.8 minus 11.2 over 1. And so I get an approximation of 1.6. Now, you have to be careful that they are asking us to indicate units of measure. So I don't want to miss that and miss that point on the exam. And so my units of measure, well, I'm taking a rate, a slope of the number of ounces per the number over the number of minutes. So I would say ounces per minute. Okay, very good. Let's move on to part B. Okay, part B is asking us, is there a time t in the interval 2 to 4 at which c prime of t is equal to 2? Justify your answer. Okay, so this question to me screams the mean value theorem. So you really have to be able to recognize that. They're asking is there a time, and this is always how these are worded, is there a time such that the derivative of the function you're looking at in the table is equal to 2? Okay, well, the only way to answer this is, first of all, to think about the mean value theorem. Does the function meet all the criteria in order to even proceed with that mean value theorem? And so if you think about it, what are the criteria? Well, remember, it has to be continuous and differentiable. And we are told in this problem that, in fact, it is a differentiable function. Okay, so c is differentiable. And therefore, if you're told it's differentiable, therefore also continuous. Oops. Okay, so we know that c is differentiable, and therefore it is continuous. Okay, and so that's important, because if we can't state that we know that, then we really can't move forward with this problem. So this statement is actually really important in order to begin it, okay? Now that we know that, and we've stated it, now we're ready to go ahead and do the mean value theorem. So the mean value theorem is simply doing the slope of the secant over the interval here and see if that's equal to the slope of the tangent, which is what we are verifying. So we are verifying that C of 4 minus C of 2 over 4 minus 2, does that equal 2? Okay, and so we are basically verifying this. And so C of 4 is, of course, 12.8 again. C of 2 is 8.8, and I'd be dividing it by 2. And so what I have here is 4 divided by 2, which is 2. So because when I do the slope of the secant, I get 2, which is what I wanted, I am able to make a final concluding sentence that by the mean value theorem, there is at least one time t over the interval 2 less than or equal to t less than or equal to 4 that c prime of t is equal to 2. Okay, and that is your answer, your conclusion, and you have to use those words by the mean value theorem, which we justified the use of when we began this problem by saying that the function was differentiable and continuous. Then we can go ahead and make that conclusion. All right, good job. Let's move on to letter C. Okay, part C here says use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of 1/6 the integral from 0 to 6 c of t dt. Using correct units, explain the meaning of that in the context of the problem. All right, so we'll get to the meaning in a little bit, but first of all, let's go ahead and just compute it. And they're asking us to use a midpoint sum with subintervals of equal length indicated by the data in the table. Okay, so and we have to go from 0 to 6. So basically, if I'm going from 0 to 6, equal subintervals, I'm looking at here 0 to 2 for my first rectangle, and then 2 to 4 for my second rectangle, and lastly 4 to 6 for my last rectangle. Okay, so all of them, remember the area of a rectangle is base times height. So I'm going to say that 1/6 the integral from 0 to 6 c of t dt is equal to approximately, again I should use the approximate symbol, approximately. Okay, so we obviously have to keep that 1/6 out in front, and then we want the base of each of these rectangles, and as I said, all of them have a base, a difference in time of 2, and so that's my common base. Now I need the heights. So for midpoint, I am going to use the heights in the middle of my rectangles. And so specifically I want the y values of the middles. So that would be, if I were to write that out, I would say c of 1 plus c of 3 plus c of 5. Okay, and so now I can go ahead and fill that in. So this would be 1/3, because 1/6 times 2 is 1/3. Okay, c of 1 is 5.3 plus 11.2 plus 13.8. Okay, so we get, if I add those up, I'm going to get 1/3 of, this adds up to 30.6. And so 1/3 of 30.6, well, basically I'm dividing this all by 3, so it's 10.2. Okay, all right, so that is my approximation for this value 1/6 from 0 to 6 of c of t dt. All right, now what I need to do now is go ahead and explain this meaning of what I got in context of the problem. All right, so hopefully as you're approaching this problem, when you're seeing a fraction in front of an integral from 0 to 6 of the function, hopefully your brain is telling you that is average value. Okay, so I would say that 1/6, the integral from 0 to 6 of C of t dt is the average. And so what is C of t measuring? And remember, the average is the only one that the units do not change. So the average amount of coffee in the cup in ounces. So we're measuring, what are we measuring the coffee in? So in ounces. And then you have to state the time interval. So from t equals 0 to t equals 6 minutes. Okay, very good. Let's go ahead and move on to part D. Okay, letter D, the amount of coffee in the cup in ounces is modeled by a new function here. B of t is equal to 16 minus 16e to the negative 0.4t. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. Okay, these last part D kind of questions are pretty regular occurrences, if you will, on these tabular data problems where they introduce a new function and they want you to basically find the rate of that function at a given time. And so you're simply going ahead and taking the derivative, because rate is telling us to take the derivative, and plugging in 5. So it's not always the same, and sometimes it's mixed up a little bit, but this one's pretty straightforward. I have to find the slope of B of t, all right, and then plug the 5 in. So I'm going to go ahead and find the slope of this. All right, so obviously that'd be 0, and then minus, I'm going to keep my constant, so negative 16. When I take the derivative of e to the u, it's e to the u, so e to the negative 0.4t times the derivative of the exponent, so du would be negative 0.4. Okay, and so if I were to go ahead and multiply negative 16 times negative 0.4, all right, well, I know that 16 times 4 is 64, negative times a negative is a positive, and then I have to move my decimal back one place there. Okay, and then e to the negative 0.4t. So that's my b prime of t. And lastly, I just need to find b prime at 5. Okay, so that means I'm just plugging in the 5. 6.4 e to the negative 0.4 and then times 5. Okay, so 6.4 e to the, all right, well, negative 0.4 times 5. Again, 4 times 5 is 20. And then just move the decimal over. So 20, move the decimal back one place, you get 2, and it's negative. Okay, so e to the negative 2. I imagine you could leave your answer like that. You also could go ahead and write it as 6.4 over e squared. And do they tell you need to put a unit of measure? They do not. So I would say you could leave your answer just like that, and that would get you full credit. All right. So that was the end of that first question. We're going to move on to 2012, and you're going to see a lot of similarities, and then there's always a new wrinkle, but there's a lot that stays the same in these questions. So let's go ahead and try the second one. Okay, so we're looking at 2012 number 1, and this one is with our calculator. Okay, so tabular data ones, it looks like it's about 50-50. Sometimes we're with, sometimes we're without. So again, they gave us a table of values, and they tell us the temperature of water in a tub at time t is modeled by a strictly increasing twice differentiable function w, where w of t is measured in degrees Fahrenheit and t is measured in minutes. At time t equals 0, the temperature of the water is 55 degrees. The water is heated for 30 minutes beginning at time t equals 0. Values of w of t are at selected times t for the first 20 minutes are given in the table above. Part A asks us to use the data in the table to estimate w prime of 12 and show the computations that lead to your answer. Using correct units, interpret the meaning of your answer in the context of the problem. Okay, so this is taking it a little bit further than part A of the last one. Same beginning, okay, which I'm going to ask you to pause the video and go ahead and do. But not only do we have to have the correct units, but we also have to interpret the meaning. So I want you to go ahead and pause the video and try and do all of that. Find estimate w prime of 12, then use the right units and interpret the meaning of what that means. All right, so go ahead, pause the video, and give it a try. Okay, so let's take a look and compare our answers. W prime of 12, okay, that's the slope, and I had to go ahead and get 2 points that were equally away from 12. So 12 is smack dab in the middle of 9 and 15. So W of 15 minus W of 9 over 15 minus 9. And so I end up, remember I can use my calculator, 1.017. Okay, and then I had to explain the meaning of that. All right, so the temperature of the water, what am I measuring? Well, I'm doing the slope of W. What is W? W measures the degrees Fahrenheit, okay, so the temperature of the water, and T is in minutes. So what is this measuring? Well, if I'm doing the slope, I'm talking about a rate. And so the temperature of the water is increasing. Why? Because this was a positive slope at a rate of, and I stated my answer, degrees Fahrenheit per minute. And I get that right from up here at time T equals 12 minutes. Okay, let's move on to part B. Okay, I love question B. It says use the data in the table to evaluate the integral from 0 to 20 of W prime T dt. Using correct units, interpret the meaning of that in the context of this problem. Okay, so first of all, something should strike you as different about this problem. Okay, well, they're asking us to evaluate the integral from 0 to 20 of W prime T dt. So this is not like a rhyme and sum problem, because a rhyme and sum problem would be asking you to evaluate. First of all, they are very explicit when they want you to use a rhyme and sum. They'll tell you if it's a trapezoid or midpoint or left Riemann or right Riemann. Okay, this doesn't say anything about that, so that's not what you're doing. What it's asking you to evaluate is the integral of the derivative of this function. So you have to tap into and be aware of, and I've brought this up in class lately, that this is the fundamental theorem of calculus. That if I want to evaluate the integral from 0 to 20 of W prime of T dt, essentially they are asking for W of 20 minus W of 0. And it's simply that easy as long as you know that theorem. So that's just 71 minus 55, which of course is 16. Okay, and so 16 is our answer, and now we have to interpret the meaning. So we just got through talking about what W prime of T stood for. Okay, it's the rate at which the temperature is changing in degrees per minute. Now, when you are doing an integral of a rate, remember we go back to just the quantity. And so what's the quantity here? Well, it's degrees. All right, so in this case, 16 would represent the total change in temperature of 16 degrees from 0 to 20 minutes. And that's exactly what we're going to write down. Okay, the total change, and remember change is that word I want you to use whenever you see the integral of a derivative. Okay, so it's the total change in temperature is 16 degrees Fahrenheit from time T equals 0 to T equals 20 minutes. Okay, so basically some sort of sentence that highlights that the total change in temperature of the water in the tub is 15 degrees Fahrenheit over the time interval 0 to 20 minutes. All right, let's take a look at part C. Okay, letter C says, for the time interval 0 to 20 minutes, the average temperature of the water in the tub is 1/20th the integral from 0 to 20 W of T dt. Use a left Riemann sum with 4 subintervals indicated by the data in the table to approximate that average. Does this approximate, overestimate, or underestimate the average temperature of the water over these 20 minutes? Explain your reasoning. Okay, we'll get to the second part of that in a second. Right now I want you to pause your video, okay, and go ahead and do that left Riemann sum with 4 subintervals. Remember, we are on a question that you can use your calculator, so this should be pretty easy. You are working from the left, so keep that in mind as you're choosing your heights of your rectangles. Okay, pause the video and go ahead and get started. Okay, so hopefully you got the same answer I did. Let's just talk through it for a second here. Okay, so the 1/20th came out front. And now I boxed in with 4 different colors to try and tell us the 4 different rectangles that I have here. So in this first rectangle, in this orange one here, okay, the base of my rectangle is the difference between my x values, the difference between my times, which is 4. And then I'm using the left height, so 55. Plus, next difference is 5 times the left height is 57.1, and so on. Okay, I typed that all in my calculator and I get 60.79. Okay, the second part of this question asks us is if this is over approximation or under approximation to the actual average temperature of the water. Okay, so in order to look at this, remember that this rhyme and sum is drawn in on a graph. So we want to take a look at what kind of function we have and make a sketch of it. And up here there was some really important information where they told us it was strictly increasing. So I'm going to go ahead and just kind of sketch for myself a strictly increasing function. Okay, so it doesn't have to be perfect, all right, but from 0 to 20 minutes, so this is my 20, I have a strictly increasing function, so strictly increasing. Okay, and so if I now wanted to draw in a left rhyme and sum, so that's starting from the left-hand side, okay, and then I'm coming over and down. Well, I would clearly say that this sum here is very much under the actual curve, and so I would say that this is an under approximation. And the reason why I can explain that is because W of t is an increasing function. Okay, and that's it. That's enough to say that because it's an increasing function, that would be an underestimate or an under approximation. Okay, let's move on to part D, the last question for the night. Okay, part D says, for 20 to 25 minutes, the function W that models the water temperature has been given, has first derivative given by W prime of t equals 0.4 square root of t cosine of 0.06 t. Based on the model, what is the temperature of the water at t equals 25? All right, so they want the actual temperature of the water at t equals 25. So this is a little different than our part D that we had in 2013 question, okay, because this time we're given a rate and we're asked to go backwards to get a temperature. Okay, so, and I'm talking about this specific time interval, 20 to 25 minutes. So hopefully you know that if you have to go backwards from a rate to get a temperature, to get a quantity, I would do the integral from 20 to 25 of the rate. Now I want to stop for a second and talk about what specifically this is giving us. I just talked about how if you're doing the integral of a rate, I want you to think about that's the total change. So in this case, that's the total change in temperature over this specific time interval, 20 to 25 minutes. So this is telling me how much the water temperature has changed in these 5 minutes. So that is not going to give me the whole temperature at 25 minutes. It's only going to tell me how much it's changed in those 5 minutes. So what do I need? Well, I need to keep in mind that I already had a temperature of the water at 20 minutes. 71 degrees is where I was starting, and then I just have to add on that change in temperature over those last 5 minutes. Okay, so what I want you to do is go ahead and pause the video, enter that into your calculator, and get an answer, and come back to me. Okay, so the answer I got when I entered in my calculator was 73.043 degrees. Okay, and so that is my answer to part D, and I am all done with this video now. All right, so we did 2 great questions on tabular data. Like I said, there's a lot of consistency, a lot of similarity in these questions as you go through, and every exam has one of these, so I really want to get good at these. We've done a few, but there's lots more to practice. We'll do a couple in class next time, if not 2, maybe even 3, and then we'll hit these in the review classes again and again until we get to that exam. All right, thanks so much, guys. Have a great night, and I'll see you in class next time.